just remember that you can post a question in the chat, and we'll be watching that. So please make it as interactive as possible. And then at the end of the session, we'll have a, kind of a NPS poll at the end. So we'll appreciate any feedback we get from that. So without any further ado, I'm going to turn it over to Kim. Kim, it's all yours.
Thank you very much, Ray. Absolute pleasure to be back at TechCon again. Some of you may recognize me through general integration modernization topics, talking about agile integration over the years. Been with IBM for a few decades now, and in the integration space for a long time. I'm circling around the integration portfolio over time, and at the moment my spotlight has landed on MQ, and so I'm close to the messaging team now. It's nice to be back in that space again. I think I first touched MQ back in the late 90s, I think it was. So I'm joined today by Martin Evans. He's a principal product manager for MQ, and he and I have been collaborating on a way of talking about MQ that takes you beyond its core function and allows us to talk about why we prioritize the things we do in the product, and we'll talk a little bit about some of the recent advances along the way. So let's move on to just a one slide, and I promise just a one slide refresher on what is message queuing in the first place. So message queuing, as if most of you didn't know already, is a way of communicating asynchronously between applications. So that enables you to be fully decoupled in many different ways from one application to another. So you're released from the fragility of the network between you and another application. You're released from the synchronous real-time communication that would potentially tie you to the availability and performance characteristics of a downstream system. And that's been a really fundamental need for systems that need to decouple themselves effectively, especially across increasingly hybrid landscapes. And just that one concept alone, that concept of a queue, enables a huge suite of integration patterns, advanced integration patterns, which you can see on the right there. And really, those are the core functions, and we could list more, but these are the most important core functions of what it means to be a queuing system. And there's obvious ones like the ability to do publish, subscribe, and exactly once delivery, and then there's sort of more subtle ones that MQ really excels in around things like transactionality and so on. And there's lots of subtle patterns around how you handle things when they go wrong. What do you do with poison messages and letters that can't be delivered and so on? And so this is really what we think of as the backdrop to what it makes what makes a queue and what a queue is able to do for you. But if that were everything, then we would we would have finished writing the product a long time ago. But of course, we continuously have to add new function. There's new functions that we need to add, but more importantly, functional completeness is only one dimension within many, many others. And so what we start to see is that there's a whole load of other aspects to what makes MQ a product that people are still very happy to be using after 30 years in the market, and it's still one of the most commonly deployed messaging networks out there. Things like resilience, the way that we handle availability and service availability and message availability, to make sure that you've always got access to the queuing system. Efficiency, how well does it run on the CPUs that it runs on, and can you scale it out horizontally and things like that. Observability, so how do we know what's going on across a complex landscape? Maintainability, is it backward and forward compatible with previous versions of the product, with previous versions of APIs? And then how do we engage with the user community? What sort of support do we provide? How do we give early access to the binaries and to the capabilities within it? Can you get involved in the process with us of deciding what's happening next in the product? Portability. Really about how many different platforms and how many different protocols can we talk in the case of messaging, and usability. We've got a complex product. What can we do to make that product more straightforward? How can we improve the education and the training? How can we make it easier to deploy in pipelines and things? And then security. Fundamentally, this is a product that is used in significant sized organizations, federal organizations that really have high expectations around security. Now, if you felt like you recognized a lot of those categories, then it's quite likely that you stumbled across one of the international standards around this concept of software maturity over the years. So they used to be ISO 9126, I think, when I first started in IT, and that was refreshed with ISO 25010. That's the one. So there are sort of software standards. We've sort of built this concept off of the back of the typical categories you would see in there. So if you recognize them, that's where it's from. And they really provide the foundations to a product that complement functional completeness, but stretch it out into lots of different areas below that are really the foundations of what makes the product a strong, mature product that you can trust in your enterprise over time. So hopefully, as we go through the presentation, we're going to pick off each of these triangles. The triangles are each equally weighted, if you like. That's, we have to think about all these things with the same degree of attention, and we have to recognize a constant evolution. So security mechanisms around security are constantly changing. Platforms that are out there are changing all the time, and so we have to be constantly evolving in a product to keep up with that. So hopefully it's clear from all of that that MQ is more than just queues. It's more than just queues functionally, but then when you start looking below the functional layers, there's a lot more dimensions there as well. Let's begin then by stepping into resilience. And I've chosen resilience first because one of our biggest changes, one of the biggest things we've had in a recent drop relates to resilience, and we'll come and talk about that in a moment. Resilience, we often in messaging, we often break that into two different aspects. So messaging availability, the ability to get to all of the messages that are present in the system at a given time. Sometimes we call that data availability. And that's done through replication, essentially, replicating things across multiple queue managers, potentially just in a metro zone or maybe even across regions. And then service availability, making sure I can always get to a queue manager to put a message, making sure that I can always receive at least some of the messages. That's service availability, which means I've always got access to do work. And then on top of that, you've also got the network resilience. So how is the queuing system managing to cope with the idea that there is a messaging network out there? And it might well be that the individual applications are speaking to queue managers that are close to them, but these queue managers are connected together through a network that's built up through MQ's channels, clusters and things. How does it cope with that? And so how does it reconnect those things, reroute messages across that network and so on? Lots of different aspects of resilience. And there's quite a history, especially to the availability aspects here. So we started off handing over the availability problem to external solutions. So consistency groups in high availability systems, for example, enabling us to replicate the data outside of MQ. Shared storage capabilities that allowed us to have a multi-instance queue manager and doing shared locks across so that you could tell when another queue manager had gone down and the first one comes up. And so that's where that's where things began, if you like. And we still support those capabilities because they're still appropriate in certain platforms. We are, after all, by our nature, able to sit across a huge variety of different platforms, and we need to make sure those different capabilities are available. We started looking at ways to integrate more closely with the individual systems we're sitting on, and especially with the operating system itself. So looking at ways to get really close to the ZeOS operating system with shared queues and things like that. The replicated data queue manager uses the Unix kernel, changes to the Unix kernel to enable the replication to happen as part of normal file I/O. And so really doing it down at that level and integrating very tightly with the operating system for efficiency and other reasons there. And the appliance borrows a lot of that technology to do that in a way that's hidden from view, because you don't need to get inside the appliance and configure it. We've done all that configuring for you, but it's using similar technologies as well. Now, that was clearly a nice step forward in terms of the efficiencies and things we could gain, but going another step again would be to say, what about if we could make this more platform agnostic? What if it didn't care too much about exactly what versions of kernels of operating system it is, or indeed what operating system it's on at all? And as things started to move into the cloud, and we started to see the increasing interest in container-based technology and the like, we started to think about what would be the most native style for cloud. So doing it natively within MQ so that it worked in a way that was suited to cloud. And so that's where we came up with the concept of native HA. And so native HA, and this has been around for a little while, but it's an important background for the new feature that's come in. Native HA is MQ performing the replication between the queue managers directly. It's nothing to do with the way the operating system works. It's nothing to do with an external solution. MQ is doing its own replication. It's doing it onto local disks. So the local disks, each separate node, and bear in mind that those nodes could be spread across a metro area, so they could be in different availability zones. It's synchronously sending data across to the other queue managers, and they're storing it in their local disk. So we've got multiple replicas. By the time you finish putting a message, that message is already stored on disk in the logs, the transaction logs that are sitting underneath MQ. And we're actually borrowing from the core technology that MQ was built on a long time ago, this idea of having a transaction log that you're appending to, and we were able to borrow from that to build out this native HA capability and synchronously replicate across them. If one of the nodes, the leading node, is to fall down, then the applications can very rapidly be moved across to another elected leading node, and then start reading the messages from that replication as well. It's very clever technology. And the beauty of it is that MQ is doing a replication. It's handing everything else to the system it sits within, which is Kubernetes, to say, you reroute things, you help me to elect leaders, you notice if things have gone up or down, just do it in the normal way that you would do for Kubernetes in a stateful set. So it's really making best use of that generic platform that it's sitting on top of. Okay, so that's got us to this metro replication. We can replicate across data centers that are relatively close to one another in the order of tens of milliseconds maximum of latency between them. But what about if we need to deal with a disaster scenario, for example? And this is where we come to needing to replicate across regions. What about if we need to be able to make sure there's a copy of everything that we have that's as up to date as possible in another region? Now, this is the classic dilemma of the speed of light getting in the way. So the time it takes to do a round trip to another region in the world, another geographical region, is sufficient that you can't do synchronous replication in that situation. If you did, it would have too much of an effect on the applications that are putting to the queues and getting from the queues and things like that. So cross-region replication for MQ, and indeed for pretty much anything that holds persistent state on disk, has to be asynchronous when it goes across a region gap. And so cross-region replication is that asynchronous communication, borrowing again from native HA technology, borrowing from the logging capabilities, but enabling you to create this replica elsewhere. In a disaster scenario, you could have a small number of messages that haven't cross that boundary. That's the challenge with asynchronous communication. But given what's happening in a proper disaster, and it would have to be a proper disaster, given that you'd have to have multiple data centers go down for this to occur, you've probably got other things to worry about than those few messages that you may have lost. If you use cross-region replication for a planned switchover, you will lose no data at all, because we can get it to do a controlled switchover where it makes sure that it's completely up to date on the recovery site before it moves across. So we can get an RPO of 0 for planned switchovers, which might be useful if you are migrating from one cloud to another or across different hardwares and things like that. So it can be a valuable way of using it for that sort of thing as well. You'll notice a link there to some materials. There's quite a few materials on cross-region replication already. There is a fantastic presentation on, let's see, that'll be day 2, that'll be tomorrow, from John Rumsey, going in much more depth than I have done, talking about what's going on. And that link should lead you to a blog post that we will be constantly adding to, so there may be more materials, tutorials and things that you'll get on this feature. This feature came out in 9.4.2. It's something people have been eagerly awaiting because it rounds off our story on containers. It gives us that DR story. We had DR, of course, available for cross-region in lots of other ways, but the container story, it really does it in a nice container native way. But as you can see across the 9.4.2 release, there are lots of other aspects taken into account as well. So think back to those triangles on the pyramid just now. There's things relating to security, so advanced message security. We'll come on to that in a moment. There's all sorts of other little bits and pieces around performance and across the different platforms as well, on the appliance and ZOS and so on. So we're constantly pushing the needle forwards on all of these different angles, just to see if we can cover all the bases, and making those priority decisions, quite frankly, based on what we hear from you. So it's always very customer focused around what sort of priorities you have, and we do our best to try and keep up with the priorities that you have, as well as having some vision for what we see coming down the road in terms of new platforms and new standards. We've got a full presentation on what's been introduced from 9.4 onwards, and with plenty of detail on the recent release on 9.4.2 as well. That'll be from Matt Lemming and Anthony Beardsmore, I think, and that one is later today. It might even be soon after this one. So, and then the next one is efficiency. So efficiency, performance, and scalability. There are lots of things going on. I mean, we've had decades to optimize the engine. We often find customers saying that MQ sits at a pretty low CPU percentage when there's even quite high volumes of traffic going through, because it's a very, very efficient engine. We're constantly bringing in things to improve that efficiency. Uniform clusters, something I'll talk about in a minute, is something we brought in a while back to help balance workload more effectively. We've got compression being used in communication of data to make sure that we effectively replicate things using the fastest mechanisms. FASP, if you've not come across that before, is a protocol that is patented that we got when we acquired the company Aspera. And it helps with network communication where you have high latency, especially with large files, lots of packet loss. Where TCP/IP typically struggles, FASP excels because it has ways of managing those kind of challenges much more effectively. We can add that onto a channel in MQ so that particular part of a messaging network isn't affected by the flakiness of the network there. And then scalability, vertical, horizontal, adding multi-threading and so on. Let's just have a look at what we're trying to achieve. And again, in John Rumsey's presentation, he'll go into this in much more detail and describe it a lot better than I've time to do. But we can bring together concepts like native high availability. We can see we've got like 3 native high availability queue managers here. We can bring that together with bringing multiple queue managers together into a cluster together to get the spreading of things across that cluster. You notice I've got a group at the top there, so the queue manager group. That's implying that we could be using the uniform clusters here, so that the applications are decoupled from which queue manager they're talking to. The uniform cluster automatically switches them to different queue managers to get the best workload across them, so that the applications are neatly spread across. If we add another queue manager, or if we take queue managers away, then it will cope with that balancing as we go through. Or if something goes down temporarily and comes back up. And you can see from those sort of hints at a graph on the left-hand side of the chart that, this enables us to get near 100% service availability, because we've always got a queue manager we can talk to. On some occasions, a queue manager might be busy swapping to another instance of a queue manager. We might have a fraction of time where we've got a lack of data availability, but you'll always have another queue manager you could do work from or put messages to. So you might not have access to 1/3 of the data of the messages for a fraction of a moment, but then it will come back again. So we do everything we can with all these different techniques to give you the highest availability possible. Portability. So this actually turns out to be one of the most important characteristics for MQ, because at the end of the day, what people use MQ for is to create a homogeneous messaging network across a heterogeneous environment. So they have a landscape that spreads maybe across on-premise mainframes. They might have appliances in their own data center. They might have hyperscaler-based virtual machines in more than one hyperscaler, perhaps, and they might have managed services as well. They want to communicate with all of those in the same way, but they want to see it as one single network. And we have the ability that's grown up over time, of course, to deploy on many, many different environments. So we can deploy on Linux and Windows and AIX and IBM I and even HPE Nonstop and things like that. So we have many, many different platforms that we can land on to extend that messaging network across those different areas. And it's the queue manager itself that's really bringing that to the surface. It's got the ability to be deployed on all those different capabilities in all those different ways, but also it's got a number of different client interfaces. So we listen to the market on this as best we can, and bring protocols to the fore when we see that they're being used in the industry. So interfaces like JMS with our native libraries sitting underneath. You can also use standard protocols like AMQP and MQTT. You can even use REST communication to work with messaging if you want. There's obviously obvious downsides with REST in terms of the fact that it's not as efficient and transactional as you would get with proper messaging protocols, but it's there if you need it. And then the portability that I mentioned across all of the different operating systems. But you can see the queue manager really is the center of providing a lot of these different aspects you saw in the pyramid, right up to the functional ones around transactionality and things as well. It's also the queue manager that enables the network. So we can spread out a set of queue managers across that landscape to provide a messaging network. It's almost certainly true that we are the most deployed messaging network in the world, given the amount of large enterprises we sit within and the kind of traffic that's going across them. And so we can spread our messaging network across that hybrid landscape, and each application need only know about a queue manager that's somewhere local to it, communicate with that. The messaging network will take care of communicating the messages across that network to wherever it may need to go. And through things like MQ clustering, we can have relocatable capabilities. So applications can move, queues can move, and the clusters will reconfigure to reroute things and sort that sort of thing out. In fact, we've got customers who are using MQ as an enabler to going to cloud, because as they move the applications, they don't have to do much changes really to how it communicates with MQ. So really nice sort of aspect that I think in a way, as messaging network is something that has always been true of MQ, but it's become more prevalent again. So it used with the messaging network between operating systems across a heterogeneous set of networks that we used to have. It wasn't all one simple internet in the past. It used to have many different networks to navigate, and MQ provided a mechanism that would allow you to span across those, leading right from one operating system sitting right next to an application to another. And so it was a network then, and it's a network now. It's a network now between different heterogeneous cloud providers, different platforms like the container platforms, virtual machines, and so on. It's just extended that reach, and it's doing that message network effect, but over a different set of platforms and capabilities. So I move on now to talk about security, and I think one of the overriding sort of concepts that's gradually become more and more relevant is the concept of zero trust. It's not a new term. I should just be, clear on that. I mean, I've been looking back to see how early the term was sort of coined, and it's like 1994. It's a long way back that the idea of zero trust came out. I think it sort of got revitalized somewhere around the 2010 sort of time frame, and it's really sort of started to focus on this idea of that you cannot assume that there are any hard perimeters that will be safe. So things like firewalls and what's the edge of your enterprise or the edge of your data center. You may well have those things in place, but you can't assume that they won't get broken through and breached. You can't assume that the people who are on the inside of that network are actually safe. At least as many hacks come from the inside as from the outside. And even what we mean by inside or outside becomes irrelevant as we start to move to sort of public cloud deployments, and we're breaking applications into multiple components in microservices architectures and things like that. And so zero trust has become a more and more sort of common concept. And moving to this sort of idea that maybe the perimeter has to be the identity of the thing that's making the call, the identity of the user behind the thing that's making the call. That identity being confirmed is fundamental to being able to establish trust. And so that almost becomes the modern firewall in those sort of senses. And so there's other aspects to it too, the principle of least privilege. We play to that in a very fundamental way, in the way that we create our container images, especially if you're deploying on OpenShift, then we comply with the security constraints, the restricted security constraints. So we've re-engineered the product so that it can run in a container that is locked down. It's not allowed to get to host capabilities, whether that's the operating system or the file system or whatever. It's not allowed to get to the platform capabilities. It can't see bits of the Kubernetes API that it's not supposed to see. And so you can safely deploy it, and it doesn't matter what happens inside it. It can't get to anything it's not supposed to. And so, we by making that step, we've effectively allowed the platform to constrain us into a zero trust model. Something we introduced really quite a long time ago, but it's always worth a quick mention, is advanced message security as well. This is very much going down that line of being able to encapsulate security down at the lowest level. So a sending application, if the data that's being sent in the message is encrypted right from the moment it leaves the client, and then it remains encrypted all the way through to the receiving application, and only the receiving application knows how to decrypt that. That is true end-to-end decryption. And many other facilities try to provide it either in motion or at rest, but this is across the piece all the way through, whether it's on the wire, whether it's sitting on the disk. In all cases, it's encrypted, and a very, very powerful feature, and it can be added to an application without having to change the code of the application. It's a non-invasive capability, so we can do that through configuration, through setting up the various certificate things on either side, and then the client libraries take care of the encryption for you. So very powerful feature from that perspective. Another way of looking at this idea of how security has changed over time is the increased encapsulation. So we start to see, we began with the very physical security of, am I plugged in? Am I patched between one machine and another? And then we moved up to the level of network addresses. Can I see these network addresses or those network addresses and subnets and so on? And then we started to look a bit more at identity and taking the identities from the operating system itself and the users and the roles and starting to use those. And then we wanted to lift away from the operating system and say, well, can I do this in a standardized way that relies on some capabilities around keys and certificates that are not bound into the operating system in quite the same way? And then what about if I could extract that even further and say, well, maybe I can have identities that are separate, that are stored in enterprise directories and starting to manage with LDAP and things like that. And the latest in that line of continued abstraction is tokens and issuers, and that concept of identity as a perimeter really starts to come in with this. And so one of our latest changes, there'll be further advances in this as we go forward, is the concept of token-based authentication. So the idea here, and I tend to think of this a bit like visas on passports. So you might have a passport, you might be able to prove who you are to a particular authority. They then give you a stamp, which is a visa that you can take to a border control. And the border control will say, yes, I'm going to let you in just based on looking at that visa alone. I can validate that that visa is true and I'm going to let you through. I don't have to go back to the person who gave you the passport or the visa in the first place. I can look at that visa and in its context, and it's okay to let you through. And so with a token that you've obtained from an issuer, then you can come to MQ and MQ can validate that you are okay without having to go all the way back to the issuer of that token. Much more efficient, much more scalable. You can use that token across multiple different places. So there's lots of advantages to that. And of course, you can revoke tokens as well. In order to make all that work together, you have to have some way for MQ to be able to retrieve information about the certificates and things that are being used to set these tokens up and the keys that are being used. And so we've also integrated using JSON web key sets in order to enable easier refreshing of the keys, so that we can so you don't have to have an administrative task to go and tidy up the MQ server, so it automatically draws those down. Once again, I'm doing a bit of advertising for the other sessions here. So, and this is going to be Thursday by the looks of the number. We've got a session on tokens, which is going to all what we've called the acronym soup of JWT, JWKS, OIDC, and plenty more. So we've got Rob Parker and Shea going to take you through a nice description of how all of that works, and I believe there's some demos in that one as well. Now at this point, I've been collaborating with Martin on this for some time, but I haven't let him talk yet. So I thought it might be nice for you to hear from Martin for a few slides as we wind up towards the end, and then I'll come back and wrap things up.
Thanks, Kim. And I must remember to plug my own session, which is coming up tomorrow on observability. You reminded me. Thanks for that. M24. All right, so yeah, Kim's covered a lot of technical stuff there. I think I'm going to be covering a little bit more of the perhaps softer topics, but equally important and equally something that makes you know, a mature product a pleasure to work with. And I'll touch on some of the things that make working with MQ and being part of that community really good fun and an enjoyable experience. So I'm going to go through these topics here and make reference to some websites and things that we've got out there. we won't flash the links up, but we'll make them available at the end of the session or in the PowerPoint presentation. When we send that out, I'll make sure we put a full list of all the links in there. So don't worry if I go over something you think, oh, I didn't quite catch where that was. Okay, so on the education front, we have extensive documentation and we build on that every time we do a new release. So we've got all the historic stuff that we've always had in, for all the capabilities that have been in the product since day one, and we obviously update that every time we do a new release. We have extensive reference and conceptual documentation in there. And one of the nice things about the MQ documentation site now is you can export that into a PDF as well. So if you want to download it and read it offline, you can do that as well. Okay, so yeah, lots and lots of documentation out there. There's also lots of sites out there actually that are not directly MQ sites that have got some good information as well. Okay, blogs and articles. So the main place I would say for blogs and articles, there are a few independent sites out there, but the main one is the IBM Tech Exchange community. I'll probably refer to that again. That's really active discussions. We have lots of events there. Great place to get help. If you don't necessarily want to raise a support case, perhaps you've got just a general question about, oh, hey, how have you guys approached this, or does this make sense? Those kind of questions. I follow that, and I'm always looking for questions that haven't been answered, but it's rare that I find there. By the time I get there, it's usually been answered. So that's a really good resource, and lots of blogs as well. Some really great blogs there. Blogs tend to be much more conceptual and how to stuff like that. So that's a brilliant source, and lots of historic stuff there as well, which is all still very relevant. Okay, next one on this list, webinars, one of my favorites. We run webinars throughout the year. We always do a webinar after a new release. I think we've got one coming up next week actually, so plug for next week, look out for that. That's what's new in 9.4.2. I often do those, but I'm not doing next week because I won't be here. I'll be on holiday, but that's definitely one to look out for, and keep following the community page there to look to get updates on any new webinars, any other webinars that come out. Okay, next one up on here, training. So we have a lot of material out there for training. We do have official training. We're in the process of getting that updated. I must admit it is a little bit out of date at the moment, but we do have plans to get that updated to the latest and greatest, so that we're covering things like native HA, cross-region replication, JWT, some of the things that Kim mentioned earlier. Okay, we also have certification as well. The certification is also a little bit out of date, so in conjunction with updating that training, we'll be updating the certification. So I'm personally responsible for driving that through, so well, I'll make sure that happens. Okay, learnability. I'm going to probably mention this a couple of times because an awful lot of great information on this site. So the IBM Developer Portal has got a dedicated section for MQ. It's got numerous tutorials and badges, so they're very step-by-step, really good, lead you through kind of tutorials. They'll take you through step-by-step, hand in hand, get you up to date and up and running on MQ. And you can also take some tests and get some badges through that as well. And again, we'll make those links available too. Okay, so still on the theme of usability, how do you make life easier to use MQ? How do you make MQ usable? On the administration side now, we have various APIs. So we've got REST APIs, we've got command line, and we also have Queue Manager YAML, which allows you to configure and build queue managers when you're running in containers. That declarative approach is something we're looking at for non-container platforms as well. We're considering how we might do something for non-container builds as well. User interfaces, so we've got two graphical user interfaces at the moment. We've got the MQ Web Console and we have the MQ Explorer. The Web Console is being extensively developed to make it much easier to observe what's going on in MQ. So the console is a great tool for having a look at real time, in the now, figure out what's going on in Queue Manager. And what we're trying to do is we're trying to make it so that it's a lot easier to find your way around and make the linkages between the objects and artifacts within MQ. So when you want to see what's actually connected to your queue, making it much easier, we're bringing some intelligence into that application so you can find stuff and get to the root cause of problems as quick as possible. Okay, so that's that one. So next one here, infrastructure as code. So yeah, I mentioned Queue Manager YAML. So if you're running in containers, if you're running on OpenShift, you can do your Queue Manager configuration in a declarative way as infrastructure as code. You can do that on any platform, but it's a little bit easier, I would say, in containers right now. But we're looking at how we can take that infrastructure as code approach and declarative configuration and make that available to you in non-container platforms as well. Especially as I think what's really key there is as we have more and more systems to manage, that approach becomes much more relevant. Okay, and same with automation. So last point there, automation. We're looking at Ansible. We have an open source Ansible module, which we're always looking at improving, always looking for feedback on that. GitOps, being as we have the Queue Manager YAML, MQ plays really nicely with GitOps, especially on OpenShift, using things like Customize and Argo CD. Okay. Next slide, please, Kim. Okay, user engagement. All right. Okay, so support. MQ has a first-class 24/7 global support team. We really do have an absolutely first-class support team. We have feedback from customers. I'm just trying to read this because I want to make sure we get the numbers right. So 91% of our customers in the last 12 months rated our support an average of 4.5. That was from our surveys. So 24/7 global, absolutely first class support. I think I've said that twice, but make sure we get that across. All right, beta program. Got an active beta with I think roughly 230 organizations signed up now, and we are accepting new joiners. So if you want to get a sneak peek at what's coming up, that's the place to do it. We also run a workshop in I think June this year, but again, we'll make the details of that available. Our colleague Pete Murphy is responsible for that. I'll put his email address in the notes. So if you want to sign up to the beta program, reach out to Pete, and by all means come along to Hursley in June if you would like to as well. Okay, developer accelerator. So as I mentioned before, the developer portal has got a dedicated section for MQ, and just again say that there are lots and lots of tutorials there to help get you up and running from a development and client standpoint. We've also got an MQ GitHub samples repository that's got lots of really great samples and templates, if you like, or blueprints for doing stuff with MQ. It'll help you get up and running quickly. Okay, community. Spoken a little bit about Tech Exchange, blogs and discussions and events. Again, so just keep an eye on that. We do run community events in various different countries around the world, always really well attended and great fun if you can make those, which actually is the last point there, isn't it? The user group. So again, that's the Tech Exchange portal. Keep an eye on that. And of course, Tech Exchange itself, the week-long event that we'll be running later on in the year. So keep an eye out for that. Okay, next slide, please, Tim. So Kim, sorry. Right, maintainability. How are we doing for time? We're good for time. Oh yeah. Okay, maintain.
Yeah, we're good.
Backward compatibility. Okay, so MQ is always. I'm smiling at my own notes here. MQ has always prided itself on backwards compatibility. Those of you who've worked for it for a long time will know that. And the thing that's making me smile is I've said, whilst I wouldn't recommend it, we do have customers that are running very old client code. So the great thing about it is that when you upgrade your queue managers, if you do have applications that are lagging a bit behind, largely they're going to work. All right. I wouldn't recommend you start running or leave your MQ clients running at V6, but we do have a lot of customers that are running old clients for whatever reason where they haven't been able to upgrade them. So we do pride ourselves on being able to support our customers as they move through their upgrades and make that life a little bit easier for them. Okay, modularity. So you can run a small bare bones queue manager that's going to be like tiny, use up barely any resource, and be a really simple, straightforward install. But you've got a multitude of capabilities you can add on to that. So not just in the availability side of things, clustering and HA solutions, but we've also got a lot of add-on or modules that you can enable for things like AMQP, MQTT, advanced message service, so secure messages at rest, a whole plethora of additional capabilities that you can enable or not as you see fit. Testability. We provide some tooling for you that is available on, I'm trying to think now, I have to make sure I put the link on that. I think that is on the GitHub site, but on there we have some performance reports that we run ourselves, but we've also got some tools that you can use. You can run them in a container or you can run them standalone that you can use to actually do your own tests. So if you're moving to a new platform or you're doing a brand new install and you just want to see how much capability the platform's got, you can use the same tools we use to run your tests. Okay, faultlessness, test coverage. Wow, we have over 300,000 test cases. We have so much testing. It's fantastic. Just looking at my notes here, I was chatting to our testing team the other day, and they said that with 300,000 test cases built up over the years, it would take months if we ran them all sequentially. It would take months and months for them all to run. We don't run them like that, obviously, we run them in parallel, but we have thousands and thousands of tests that we run for every release, and we're constantly running to make sure that MQ remains as solid and reliable as it always has been. Okay, last slide, please, for me, Kim. Thank you. Observability. Tracing. Tracing metrics, logs, and events. One of the things we've been looking at more recently is open telemetry. So we are looking at how we can make all of those, what open telemetry call the 3 pillars of observability available. We have tracing. We have lots and lots of metrics in MQ. We do have a means to get those out through an open source project, which again, I'll put a link in for to open telemetry. We're also looking at how we can make that available within, or certainly supported within MQ itself. It's not there yet, but that's something we're looking at. Logs and events. We have logs in JSON format, which can very easily be pushed onto an open telemetry collector. Always add logs, obviously, and always being extensive in their level of information. We also have events, which get pushed out to queues right now, and we have some tools that will allow you to take those events and push those onto OpenTelemetry as well. That's a sample program. I'll talk a bit more about that in my observability presentation tomorrow, but we do have this sample now that's written in Go, and you can take that and use it to get all of your events, like the performance events, audit events, those things, out into an open telemetry collector and set up monitoring and alerting on those. Real-time diagnostics, touched a bit on the console there. So the console is available for I would say easier diagnostics. If you want to have that, just click through and find out what's going on. Obviously, we also have the command line But the console is where we're really investing a lot of time and effort into making it much easier for you to get in there and figure out what's going on with your queue managers quickly and take actions. And obviously we have command line there as well. Generally, I would say what we're trying to do is just make MQ more observable and much easier to configure to make it observable as well. Just want to check my notes to make sure I haven't missed anything off of there. Oh, just to say that OpenTelemetry tracing was available from 9.3.5, but you can use it with any supported version of MQ. All right, so it doesn't have to be 9.3.5. It can be a 9.3 LTS if you want to turn on tracing. Yeah, and I think that's pretty much everything from me, Kim.
Amazing, thanks very much. So hopefully what we've given you is a good feel for the type of things that keep us up at night when we're having priority decisions around what to add to the product in MQ. We're obviously listening to you very carefully as to what sort of things are prevalent for you, what hyperscalers, what platforms, what changes in security paradigms are happening, and that sort of gives you some idea of, you know, how we wrestle with the importance of these different things. Just to wrap up then, I'd like to have a think about how you see MQ. What do you think of when you see MQ? And I think I'd like to sort of change the dynamic a bit and have people think of MQ as a light, nimble framework. We run, as part of our services, we run MQ on fractions of a core, 20th of a core we can run MQ on. So it's a very lightweight capability, very fast, starts very rapidly. It can go as fast as you need it to go for you know, realistically for most messaging applications. We've got performance tests on the mainframe and on appliances where we've seen MQ going it up to 1 million messages a second. So obviously there's, you know, certain configurations we're doing to get it to that level, but you know, it's got the power to do that with parallelization and everything else. So we've got a wide range of communication protocols to cover lots of modern languages as well as the old legacy languages that we used as well. So all sorts of different mechanisms there. So you know, you should be able to connect with your messaging network wherever you need it. And we've gone to great pains to really embrace cloud as a technology. And by that, I don't just mean that, you know, it's available in hyperscalers. What I mean is we've really changed the product and re-engineered it to work well in containers. I think native HA and CRR that we were talking about earlier are a great example of that. The use of the security context to restrict things is a good example of that. That sort of shared nothing, minimal dependencies architecture that we're focusing on really is designed in the way that you would build applications if you're building them as microservice applications to really take advantage of a cloud environment. That's what the product looks like today. It's a very different product to you would have known many years ago. Indeed, you know, it used to be the case that you would choose to put tens, even hundreds of queues onto a queue manager. You still can, but it's lightweight enough now that you could run it with just a handful of queues on a queue manager, have queue managers that are sitting locally to individual applications and things. In many ways, we're almost going full circle back to that more decentralized style where the network reaches out to the applications if it needs to. But then, of course, you can also have MQ running centrally as a service as well. So you've got the best of both worlds there. And that allows us to build these messaging networks that can stretch across a hybrid environment, across all sorts of different platforms and capabilities. And so we can provide that that trusted once only delivery but we can do it across that messaging network, and MQ's dealing with the problem of getting across the network for you and getting between those different platforms and operating systems. You don't have to worry about that when you're trying to communicate with something that's at a remote distance and is indeed potentially moving and migrating to a different place. So that's, you know, if you're talking to your colleagues about MQ, I'd like you to have this in mind as the MQ is perhaps, if you've been working with MQ for some time, just recognize how much MQ has changed over that time, and let's try and make sure we're using the right language to remind people where it is today, because it's a very different animal to it maybe was that long time ago. So with that, I've come through all the things I wanted to talk about. I'm just going to check in with Martin, because you may have been able to keep an eye on the chat, see if any questions have come in that either you haven't had a chance to answer or are worth surfacing here.
Thanks, Kim. Yeah, I think I've answered most of the questions. I'm just checking. One has just come in. I was missing async API as one of the standards. Yeah, we do have async API for MQ. That's come from Melis. We do have that, and that's definitely something that we are planning to continue with.
Yes, it's an interesting one, because the async API standard itself is changing very, very rapidly, and so that's another thing that we're having to keep pace with. In fact, you know, in another product across the integration portfolio, Event Endpoint Management, they're having to insulate themselves from that standard because it's changing so fast. But it is a very relevant and important standard for us to enable us to describe queues in a declarative way. Another bit of open source that I didn't mention on the way through, but I always think is worth just pulling out, is serverless frameworks and CADA. So there is a open source framework for using queues, to the depth of queues, to decide whether to start containers. So whether it's an integration engine or whether it's an application engine like Webs for Liberty, you can decide whether to start that container based on the depth of a queue, and if there's nothing in the queue, then you can scale right down to 0. And we've added what's called a CADA scaler to that open source project to enable you to use that with MQ. So just another open source piece that you guys might be interested in. Any others there, Martin?
There's a question about Aptio. I'm not actually familiar with Aptio myself, though.
No, I can't say I am either, to be honest.
So I would say there's nothing in plan, because neither Kim or I know about it. So if there was anything in plan for MQ, Aptio, we would know about it. How are we for time? Do we have any?
We're doing well. We're going to wrap up here in just got another couple of minutes, but this is a good place to break. So Kim, Martin,
I was just going to add one thing, Ray, if that's okay.
No,
just thinking about the async API. One thing I would say on that is one of the things we're thinking about and talking about is declarative infrastructure as code, configuration as code, and configuration from code as well. So trying to tie all that together, I think async API plays a part of that as well. So being able to self-service your developers, have MQ play nicely in your platform engineering and all those good things. You know, that's something we've got a keen eye on at the moment. Personally, I've got a bit of a laser focus on it, you could say. So definitely something we're looking at for the future.
Just to wrap up that async API discussion, so we presented at the async API conference last year, I think it was. Dale Lane presented there on a piece of work that I've been collaborating with him on around topic characteristics. So when we're thinking about where async API might go and what kind of information about queues and topics you might want to store in it, we did a bit of research around all the different possible things that you might want to place in there, and presented that to the Async API conference in London. If you want to have a look at that, if you're really into Async API and you want to see some of the research we've done there, just search for my name, Kim Clark, and topic characteristics, and I suspect it will come up. So Medium article there.
All right. Okay. All right, gentlemen. Well, thank you. We're coming to 5 minutes after the hour. We're going to have a little bit of a break here. We're going to start back at 20 minutes after the hour with a little shift in gears, where we'll be going to the event-driven architecture side of the house a little bit with a topic called Death to Zookeeper, Expose K-Raft and Kafka. So that will be starting up at 20 minutes after the hour. Please take the survey at the end of this one, and we're going to have a guest speaker kind of this time of day tomorrow and on Thursday, the co-inventor of Siri. Okay, so yeah, that should be interesting. I'm looking forward to that. So thanks everybody for joining. Don't forget we have office hour that wraps up today, and we'll see you at 20 minutes after the hour.
Thanks everybody. Thanks, Ray.